Our last science speaker in this session is Dr. Rob Massom, who's going to talk about Antarctic sea ice and why it matters. Rob leads the sea ice team at AAD. He's a world-renowned climate scientist, and I don't say that lightly. He specialises in sea ice remote sensing, physics, and cross-disciplinary research. Despite terrible seasickness, he has participated in 15 sea ice campaigns in the Antarctic and the Arctic. His research findings include identifying links between sea ice and ice shelves and between sea ice variability and penguin breeding success. And I was really delighted on my first day at AAD to encounter Rob as this genuinely interdisciplinary scientist with an incredibly inquiring mind. Rob.
Well, thank you very much for those kind words, Nicole. Good afternoon, everybody. I'll cut straight to the chase. The take-home message is that Antarctic sea ice and what happens to it really matters. So sea ice knowledge and monitoring, it's really crucial to addressing our strategic science priorities around climate and krill, as we've been hearing about. It's really important to robust climate and environmental assessments and predictions, such as the IPCC. And it's also important to predicting sea level rise and also supporting policy decisions around marine conservation and management, for instance, and also safe operations. As Charlton said, within the sea ice zone, we need sea ice information in order for the ships not to get stuck, hopefully. And it's also important for weather forecasting in Australia and around the region. So sea ice is an absolutely crucial component of the Earth's system. Each year it covers between about 3.5 to 19 million square kilometres of the Southern Ocean. 90 million, that's about 2.5 times the area of Australia. By forming a really bright surface and reflecting up to 85% of incoming solar radiation back out to space, by capping the interaction between the relatively warm ocean and the cold atmosphere, and also, I've forgotten what also is, so I'll move on. There's something else that's important, but it exerts a controlling influence on the heat of the Earth's surface and the weather and climate system. And also the properties and circulation patterns of the ocean, as we've been hearing from previous talks. And it's absolutely fundamentally important as a habitat for a whole plethora of biodiverse creatures, from minuscule phytoplankton right the way through to whales, and not forgetting benthic communities as well, and of course krill and penguins. And it plays a key role as well in modulating processes involving the ice sheet. And of course, it affects human activities around Antarctica. So another take-home message is that sea ice change has serious, wide-ranging consequences, not just for Antarctica, but for the wider Earth system as well. So as Matt said earlier, Antarctica is full of surprises, and the sea ice is one of those surprises. After tracking upwards slightly over the satellite era, which is since 1979, overall Antarctic sea ice extent suddenly decided to go upwards, and we had a number of record highs in overall extent from about 2012 to 2015. But then all of a sudden, again unexpectedly, it plummeted downwards from about 2016 onwards, and it's been tracking below the long-term average ever since. And for instance, in July 2022, we had a real record low, which was about 1.1 million square kilometres below the long-term average. That's about the size of New South Wales. But this change around Antarctica, it's really not uniform. It has different regional and seasonal contributions. This is shown in the satellite image on the right-hand side there from the 27th of August of this year. And you can see the reds, which are the loss regions, but also there are some regions of gain. So there are complex processes going on around here involving interactions between the sea ice, the ocean, and the atmosphere, which differ around the continent. And I suppose a real concern is whether this unexpected behavior, whether it heralds some kind of a regime shift in the ice-ocean-atmosphere system, which is similar to that which is occurring in the Arctic, for instance. Less sea ice means more heating of the ocean, which could lead then to less sea ice, which could precipitate an unstable system. So west of the Antarctic Peninsula is an area which has seen particular loss of sea ice, and the map on the left shows decreasing duration. It's the annual duration of sea ice coverage, and that region west of the Antarctic Peninsula has seen a decrease of about 2 to 3 months of sea ice duration since the 1970s. And one of the things that this has done is exposed ice shelves in the region to the open ocean and to wave effects. It's removed a protective sea ice buffer offshore from the ice shelves. And it's believed that this played some role in the loss of the Larsen B ice shelf, whereby 3,200 square kilometers of ice shelf suddenly disintegrated in about 2 weeks period in early 2002. So that area was previously locked in by sea ice, but recently it's been open to the elements. And this particular ice shelf, once it broke up, it led to an 8-fold acceleration of glaciers feeding into the ocean, which contributed to sea level rise. Coming on to what Stephen was saying earlier on about happy feet, this is showing the effect of the sea ice change in the region, the loss of sea ice duration, the shorter duration, on the number of penguin breeding pairs. And actually, Adelie penguins in the region, this is at Palmer Station, have diminished since the 1970s by about 80%. This is in reaction to the loss of sea ice. So I suppose that's unhappy feet for the Adelie penguins, but they're a happy feet for the Gentoo and chinstrap penguins. Those are subantarctic ice tolerant species rather than ice-loving species, which have moved in to take the place of the Adelie penguins. And this particular example really does highlight the crucial importance, which has been shown in other studies by Barb and by Johnny and others, of integrated long-term monitoring to pick up these kind of changes across the whole system, physical and biological. In this case, it was the Palmer Long-Term Ecological Research Program. So IPCC, a major priority, and one of the motivators of our work is to improve Antarctic sea ice representation in models. And you can see in the plot there, the blacks and the red line there, it's a satellite record extended back by proxy measurements. And the blue is the range of model simulations of sea ice extent around Antarctica. You can see quite a strong discrepancy between the two there. And extending into the future, there's quite a large range or uncertainty in what these models are telling us the sea ice system should do. So this leads to low confidence in model projections of future sea ice evolution and the impacts as well. So what this is telling us is we are really lacking reliable observations and also process understanding. And we need to also improve Antarctic sea ice representation. It's critical to climate prediction and weather and sea ice forecasting also. So what are the pressing questions? Well, there are quite a number that need to be answered, but related to climate, what's driving Antarctic sea ice variability and change that we're seeing? And from an ecological perspective with sea ice, what are the links between sea ice primary production and Antarctic krill, for instance? Now, how do we go about this? Well, it's a major challenge because we're interested in the microscale, microns, right up to thousands of kilometers. So how we go about this is the need to collect in situ measurements. Central to what we're going to be doing in the future is this quantum leap that Noina is going to be bringing to us in terms of taking us down to the ice, enabling us to monitor the ice as well. And on the other end of the scale is use of satellites. They're absolutely key to giving us the large-scale picture. But it's the autonomous underway systems, it's the autonomous underwater and airborne systems which are key to linking our in situ measurements with the large-scale measurements. And the models bring all of this together. And again, to reiterate, there's an absolutely crucial importance of collaboration, not only within the Antarctic program itself, that's including ACES, AAD, SAFE, and AAPP, of course, but internationally, and again, transdisciplinary. It's absolutely essential that we collaborate across the disciplines rather than just in our own narrow disciplines. And for those who are interested, we've recently put together these high-level synopses. They're aimed at policymakers. They've been put into the SCAR Antarctic Environments portal, the aim of which is to link Antarctic science and Antarctic policy. And one is on sea ice physical role and function, a second one's on biological importance, and the third one is on trends and future projections. So if anyone's interested in this particular area, please have a look at those. Thank you.